All right, here what we're gonna look at is the simple population growth model. And this model is A equals A0 e to the kt power, where A is the population at time t, A0 is the initial population at time t0 equals 0. K is the growth rate constant. So let me just point out that K is pretty common, the constant, and T definitely for time. Sometimes we use a different letter like Y, Y0, and it's pretty common to use Y0 and Y, or P for population, P0. So let's go ahead and write down an example here. Actually, before I do that, why don't I go ahead and just remind ourselves what the exponential graph looks like. It's something like this. Now, notice that if you put t as 0 here, so look, if t is 0, then you have e to the 0 power, and e to the 0 power is 1. And so therefore, when t is 0, I get a0. So this point right here is our starting point, and that's at a0. And then we have this exponential growth where it can start growing very quickly. I mean, it does. So it goes up like that. That's, generally the shape of the curve. So, okay. So we're going to look at this problem. The population of bacteria in a cup of milk is given by A equals 6 e to the 0.3 t power, where t is time in hours, and A is the population. All right, so the idea is that you have some milk and it's sitting on the counter, and you're thinking, well, how long is it going to take until the milk gets sour or turns into yogurt maybe? So let's go ahead and find the population after 5 hours. So the solution is that we plug into this equation. So we put in t equals 5. So that's 6 e to the 0.15. Now, many people don't feel super happy about that, because that's not a number that I can really get a hold on. So you could put this in a calculator, but when I put in the calculator, I'm going to get a decimal approximation. So that's around 6.97. So that didn't really grow very fast. The problem is I made a mistake. That's why. I was wondering, what the heck, why did I get that number? Sorry, that is not right. It's 6 e to the 5 times 0.3 is 1.5. Okay, I thought something was going on wrong with that. And that makes 26.8901. That's an irrational number. So it's up to us where we want to round that. So that's an irrational number. So the exact value is in fact this. Okay, so next question is B. When will the population reach 3 billion, which is 3 times 10 to the 9? So what we're going to do is here's our solution, which I guess I'll end up doing on a different piece of paper. Okay. So this is this will allow us, this is going to get us to use some more of our math that we learned. Okay. So here's the solution. So the solution is that we're given A equals 6 e to the 0.3t, and we're given that A is equal to 3 times 10 to the 9th. So, and then what we're trying to do is we're trying to find t. So it's sometimes a really good idea when you're doing a problem to write down what you're given and what you're trying to find, so that you have a clear idea of what you're trying to do there. And so I'm going to put everything in there, but see, what I don't have is I'm trying to find t, and t's way up here. Well, what do we do? Okay, so we're going to solve by first isolate the exponent. And so I'll have 3 times 10 to the 9th divided by 6 equals e to the 0.3t. All right, I guess I'm going to reduce this. 3 divided by 6 is a half, and that's 0.5. And then to make it look better, put in scientific notation, I'm going to move the decimal to the right. So that should make 5 times 10 to the, well, let me write it this way, so I'm sort of afraid I'm going to make a mistake here. So this is true. 10 times 10 to the 8 is 10 to the 9, and 0.5 times 10 is 5. Okay. I think I didn't have to do that extra step, but I did. Now what I'm going to do is I'm going to apply ln. So I'm going to apply ln to both sides, and that's our standard thing to do when we have our unknown sitting up on top as an exponent. And then because I have base e, ln and e cancel out, and I get 0.3t. And divide by 3, or 0.3. And there you go. It's sort of fun to put in the calculator, but don't need to do that. But I'm getting that as 66.767 hours, so I'll say that's around 67 hours. That's approximately. This is our answer. But I like to sort of see what's going to happen. Somehow I'm not really totally convinced that's right, but I think all the steps are okay there. But I sometimes am concerned that I'm doing something wrong on the calculator. So, but I think that's right. Okay, I'm going to double check on that I did that right. So using the calculator, I mean, all the other math is right. Let me just make sure I put enough parentheses. Okay, yeah, I think that's it. All right.